Open your book to page 315 and let's go to number 17. Number 17, you have the point P at 3, -4, 5, and point Q at 5, -6, 3. And you're looking for the midpoint between the two. Again, the quick way to do it, just average the two. So this, when you average, you get 4. Average, you get -5. Average, you get 4. Okay. But again, you want to use the easy problem to practice with your vector scale. Okay, so first let's go ahead. Since it's three-dimensional, we're not going to use the coordinates. So we're just going to just use the vector without the axes. So first, just go ahead and just sketch. Again, all these are arbitrary. So this would be vector P. And vector P is going to have a 3i minus 4j plus 5k. Right? So 3, -4, 5. And just go ahead and, again, just make any direction. Again, all this is arbitrary. So this is vector Q, and it's going to be equal to 5i minus 6j plus 3k, right? 5, -6, 3. And then after this, again, you're looking for midpoint between the two. So your midpoint would be right over here. So that would be the midpoint. But before you do your midpoint, you have to get this vector. So this vector PQ. The reason this is PQ because you're going from P to Q, so from P to Q. And the vector PQ, again, to find out the vector, you use the end minus the beginning. Right? This point is 5, -6, 3, right? And this point is 3, -4, 5, right? From this, right? So vector PQ would be 5 minus 3 would give you 2i, right? -6 minus -4 would give you minus 2. J, 3 minus 5 will give you minus 2k. Okay, so now let's go and find the midpoint. So again, the midpoint, imagine that this is a lake. So if you can fly over, this would be your vector M. This is your vector M, right? So your vector M is going to equal to, but since you cannot fly directly over, so you have to kind of follow the path along the lake. Okay, so it'd be that way, so you have to follow this way. So vector M is equal to vector P, right? So from here, you go over here, plus 1/2 of the PQ. Right? Again, this is half the PQ, right? So you can look at the map. So this vector M is same as vector P plus 1/2 the PQ. Okay. So your vector M, you just go and substitute everything in there. So you got 3i minus 4j plus 5k plus 1/2. Okay, PQ is 2i minus 2j minus 2k. So then go ahead and work it out. You got 3i minus 4j plus 5k plus I minus j minus k. So your vector M is going to equal to 4i minus 5j plus 4k. So again, this is the vector M. If you're going straight from here to here with, by flying in the helicopter, then you can just go directly. That's what you're going to get. So the coordinate of the M, so you can notice the difference between the two. This one has a little arrow, so this is the vector, okay, and this is the point. So point M would be 4, -5, and 4. And that would be your answer for number 17. Okay. Okay. Let's go to 21. You have point P at 5, 1, -1, and Q at 11, 10, 5. Okay, so you can just go ahead and draw any arbitrary vector. So this is the origin. Origin is where you start. And so point P over here, this is point P, so it's 5, 1, -1. So here's your vector P. Okay. So vector P would be 5i plus j minus k, right? So again, 5, 1, -1, right? And then go ahead and I'm going to just go and make a Q really long. So here's point Q, 11, 10, 5. So here's your vector Q equal to 11I plus 10J plus 5K. Right? Again, all these numbers should match. Okay, so you're looking for the trisection point. Trisection point means you divide this into 3. Okay, so it's about like right over here. Okay, so I'm going to call this T1 and call this T2. Okay. So these are trisection point. Again, so first, let's go and do the T1. So to get T1, you have to go from here, you go to P, and you go over here, right? But again, first, we need to go and get our PQ. So this vector over here, this is the PQ vector. So PQ vector, you just subtract, right? So 11 minus 5 will give you 6I. 10 minus 1 will give you 9J. 5 minus negative 1 will give you plus 6K. Okay. So by looking at this, you can see that T1, okay, so again, here's your vector T1. If you go in the direct path, okay, so that's your T1. So that's your vector T1, right? So the vector T1 is going to equal to vector P. So again, to go from here to here is same as you go to here first. So that's P plus 1/3 PQ. Okay. So just now next go and substitute. So T1 vector is equal to 5I plus J minus K plus 1/3 times 6I plus 9J plus 6K. So go and work it out. 5I plus J minus K. Multiply, so you're going to get plus 2I. Multiply, you get plus 3J plus 2K. And go and combine like terms. So T1 vector equal to, you give me 7I plus 4J plus K. So T1, the point T1 would be at 7, 4, 1. Now you do the same thing with T2 to get this point. Okay. So T2 vector would be, again, if you go in a straight path, then it would be direct flight, right? But since you cannot, so you have to go ahead and go this way, so you have to go to P1 and go 2/3 of the way. Okay, so this is the blue one. So T2, vector T2 is equal to vector P, so you have to go to P, then you have to plus 2/3 of the PQ. Right? So you have to go there and you have to go there, and this is 2/3 of the weight, right? So substitute everything in there. So you're going to get 5I plus J minus K plus 2/3 times 6I plus 9J plus 6K. Then go ahead and work things out. So you got 5I plus J minus K plus 4I plus 6J plus 4K. So T2 vector equal to, you can combine the like terms, so you're going to get 9I plus 7J plus 3K. So your T2 point would be at 9, 7, 3. Okay, so those are your trisection points. Okay. But the key is make sure you understand the vector. It's just like the treasure map. You're following the path, for the direction and the length, and you just go and use vector and you write it out and you work it out.